Hello friends, this video on relations and functions part 14 is brought to you by examfear.com. Before watching this video, please make sure that you have watched part 1 to part 30. Take one more example. Here we have to show that the relation R in the set of real numbers, please note the real numbers, defined by R, the relation is defined by A comma B, where A is less than or equal to B square is neither reflexive nor symmetric nor transitive. So the first thing for reflexive what I told is if A comma A is a member of set for all A, right, for all A belonging to real numbers, because I'm talking about real numbers. So if I can prove that A comma A is not member of this, then that means it is not reflexive. So A comma A, if A comma A is member of this, then A should always be less than equal to A square. But this is not true always. Since we are talking about real numbers, we take example, for example, 1 by 3. 1 by 3 is not less than equal to 1 by 3 square, that is 1 by 9. This is not true because 1 by 9 is less than 1 by 3. Since we are talking about real numbers, this statement fails. If we talk about, let's suppose instead of real numbers had this been natural number, then this was true. But since we are talking about real numbers, this is false. So students, please note that, understand the question properly. Try to see what is the domain, what is the range. For example, I am talking about real numbers here. What is the relation here is equal to, greater than or less than. Those things, minute things, has to be noted carefully. Because the same relation, if you just change the set of R from real number to natural number is reflexive. But the same relation, if you make the set of R as real number, is non-reflexive. Correct? So this is one scenario where we have to understand this part also. What is the range, domain of the bigger set? So here it is real numbers. So for real number, this scenario fails. So it is not reflexive. Correct? Second thing is symmetric. For symmetric, I told if A comma B is member, this should imply B comma A is also member. So if A comma B is a member, I am assuming A is less than or equal to B square for some A and B. But this does not mean that B square or B is less than or equal to A square. This does not mean, right? This does not mean this. So we can say that this and this is not same. So if A comma B is a member, then B comma A need not be member of this set. So it is not symmetric also. Third thing is the transitive. For transitive, what I told? For transitive, I told if A comma B is a member, B comma C is a member, this should imply that A comma C is also member of this relation set. Now we'll take some example. For example, we take A is 5 and B as, let's suppose, 5, 3. So B square is 9. So B square is 9 is greater than equal to 5. Correct? Now let's take here 3 because B has to be 3. And C, let's take 2 because 2 square is 4. So if you see this, now with this should assume that 5 comma 2 should exist. But if you see 5 comma 2, if I try to get this relation, 5 is less than or equal to 2 square, this relation is wrong. Because 2 square is 4 and 4 is not greater than or equal to 5. Thus, this is one scenario where transitive property fails for this condition. So this is not even transitive. Please note the reason why we took 5, 3 and 3, 2 is a little tricky here, because if we take other number, for example, if we take 5, 6 and 6, 7, let's suppose, this will be true. To prove that it is false, we took this number because we took this number lesser than this. Correct? Because if you see, if I take 2 here, 2 square is 4, 4 is less than 5, this is not true. So I took the minimum possible number, so I took 3, 3 square is 9, 9 is okay. Here I took 2. If I take 1, 1 won't be true, 1 square is 1, 1 is not greater than or equal to 3. So I took 2, 2 square is greater than or equal to 3. So in this scenario, this came out after a lot of thoughts. It just didn't come out. You need a lot of practice, you need to think a lot before choosing this number. So to choose this number, what we have done is, we took A as a number and we took the least possible value of B which is satisfied by its condition. So here we found 3 is the least possible value. B we took 3 because B has to be 3 now. C again we took the least possible value of C that should satisfy the condition, and we saw that then 5 and 2 is not matching our criteria. Any number you can take any number that proves that it is not transitive, that will do. Let's take one more example. We have to check whether the relation defined in the set 1, 2, 3, 4, 5, 6. This is my whole value of range, where B is equal to A plus 1 is reflexive, symmetric and transitive. We have to check. So for reflexive, I told A comma A has to be member of the set. If A comma A is the member, I will write like this: A comma A. A is equal to A plus 1. A cancel, 1 is equal to 0, which is a false statement. So we can say that A comma A is not a member of this. So reflexive is gone. Very simple. See, for this to be reflexive, A comma A should be member of this, but we can see that A comma A is not member of this. So this is gone. Second is, we have to prove whether it is symmetric or not. To prove it is symmetric, we have to prove that if A comma B is a member, B comma A has to be member. So if A comma B is a member, I am saying that B is equal to A plus 1. And if B comma A is a member, I am saying A is equal to B plus 1. Both are different. Thus we can say that if A comma B is member, B comma A need not be member, because both are contradictory actually, right? If I am saying B is equal to A plus 1, A is equal to B plus 1, both are contradictory. Next come transitive. See, for this to be transitive, I told that if A comma B is a member and B comma C is a member, this should imply that A comma C is also a member for all these values. Correct? So if A comma B is a member, A and B is nothing but A plus 1, A and A plus 1 is a member. Now we have to make B as this one only, so this is A plus 1. So C will become A plus 1 plus 1, correct? This will become A plus 2. These two are members. So if these two are members, this is transitive only if A and A plus 2 is member, because C is A plus 2 here. But if you see, A and A plus 2 are not member of this, because A and A plus 2 will not be satisfying this condition. This condition is nothing but B, that is, this is B and this is A actually. If you see, B is equal to A plus 1, that is A plus 2 is equal to A plus 1. That is a wrong statement. 2 is equal to 1 is a wrong statement. So we can say that this is not transitive. So if you want, you can solve this question by finding the values of this relation set, but that is a little tedious process where you have to find the values. This is a little simpler one, where reflexive I prove that A comma A is not member of this. For symmetric I prove that if A B is member, B A is not member. For transitive I said that if A, B and B and C are member, then I use this formula B is equal to A plus 1, so instead of B I made A plus 1. Here C is equal to B plus 1, so C is nothing but this A plus 1 plus 1, A plus 2 I got. So I had to prove that this is not part of this set, and I proved that this is not part of this relation, so this is not transitive. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.